Hello and welcome students. This is lecture number 2 on functions. In the previous lecture of functions, I defined function for you. I explained you how a relation from set A to set B. I explained you that how a relation from set A to set B, a relation from set A to set B can become a function from set A to set B. I repeat again, what did I teach you in the earlier lecture? I taught you how a relation from set A to set B can become a function from set A to set B. Remember students, not all relation will be function. Remember this, not all relations are functions. If you have a particular relation, say there is a set, and this set is a relation. This set is a relation. Now the question is whether this set is also a function. The answer can be yes, the answer can be no. Either of them are possible. Either of them are possible. So remember that all relations are not functions. At the same time, if you have a function, suppose you got a set, you have a function. So if you have a function, then it is always a relation. It is always a relation. It is somewhat like if you have passed, if somebody has passed 10th standard, if somebody has passed 10th standard, then whether the person has passed 12th standard or not, the answer can be yes, the answer can be no. If somebody has passed 10th standard, has the person also passed 12th standard? The answer is maybe, may not be. Okay. But if somebody has cleared 12th standard, it means definitely the person has cleared 10th standard. So a relation may or may not be a function, but a function is always a relation. Function is always a relation. Function is always a relation. We also learned that there are few conditions which has to be satisfied, then only a relation can become a function. And then we solved few problems. Let us solve few more problems. There is one diagram on the screen that you see here. You have set A, then set B. What do you notice? You notice this. See, such diagrams are known as arrow diagrams. You notice that from the elements of set A, there are arrows which are originating and terminating on the elements of set B. Got that? Now here, what I notice is all the elements, see here, all the elements of set A are associated, all the elements of set A are having their images. All the elements of set A, that is P, Q, R, S, they all are having images in set B. So the first condition is satisfied. What if you are having a correspondence, if you are having a correspondence from set A to set B, then all the elements of set A should have image in the set B. So the first condition is satisfied. What is it? Every element of set A has an image in set B. This is satisfied. But but look at the next condition. What I notice is from one element which is R, there are two arrows originating. So what I notice that element R of set A does not have unique image. R does not have unique image in set B. See, it has two images. It has one image B, the other image D. So this is not a function. It is not a function. This is only a relation, not a function. Got that? So the first condition was satisfied. The first condition was satisfied. But the second condition was not satisfied. What was the second condition? That every element should have an unique image. So what I will write from set A, I will write here from set A, the element R does not have unique image in set B. I hope it's clear to you all. Now let's go for the next one. What do you all have to say about this particular correspondence? Okay, here you will write the final answer. What will be the final answer? The final answer will be therefore, the above correspondence, this is a correspondence, above correspondence or above relation. Okay, let us write above correspondence is a relation from set A to set B, but not a function, but not a function from set A to set B. This you will write. Okay. Now let's come for the next one, students. See, the next one is here. The next one is C. The next one is C. What do you notice here? There is a correspondence. Okay. And this correspondence is once again, it is a relation, but it is not a function. Why? You can check it is not a function from set A to set B. Why? Because this element of set A, see, when you say from set A to set B, remember, every element of set A should have an unique image. But what I'm noticing that there is no image of this element in the set B. There is no image of this element in set B. So I will say here, I'll write the given correspondence or the above correspondence, whatever. The given correspondence from set A to set B is a relation, but not a function. What is the reason for this? I will write here. The element -2, from set A, the element -2 from set A does not have an image. It does not have an image in set B. It does not have an image in set B. I hope it's clear to you. Please write it down. Students, let's now come to question number 2 here. See, it says which sets of ordered pairs represent functions from set A to set B? Justify. Now see, they have given us in this question, they have given us the set of ordered pairs. We have to state, we have to state whether a given set of ordered pairs like this, see, these are ordered pairs. These are ordered pairs. What we have to do? We have to state whether this set of ordered pair is a function from set A to set B. Okay. Let's go ahead. See, remember one thing, students, that each one of them, is going to be a relation from set A to set B. Why? Because see, I have A and I have B. So in A, how many elements I have? In A, I have 4 elements, and in B, I have 5 elements. So if I write A cross B, remember, if I write A cross B, so how would A cross B come? If I'm writing A cross B, so A cross B will have 20 elements, and what will they be? 1 minus 1, 1 0, 1 1, 1 2, 1 3, like this, then 2 minus 1, 2 0, 2 1, 2 2, 2 3, 3 minus 1, 3 0, 3 1. See, this is A cross B. Set of ordered pairs where all the first elements are from A. Then you have 3 2, 3 3, and after that you have 4. You will have here 4. You will have 4 minus 1. See, 4 from set A, 4 0, 4 1, 4 2, 4 3. Okay, this was A cross B. Now you can check. Look at the first one, A. This ordered pair, is this a subset? Is this ordered pair, I'm sorry, is this set, let me name this set as, say, R1. This set, R1. Is this set R1 a subset of A cross B? Yes. Why? Because all the elements here are already there in A cross B. See, 1 0, 3 3, 2 minus 1, 4 1, 2 2. Okay. So definitely it is a relation. But now the question is whether this R1 is also a function. So for function, what is the condition, my dear students? The condition is every element of set A should have an unique image. So start. In set A, what you have? 1, 2, 3, 4. So check. 1 is there, 2 is there, 3 is there, 4 is there. Okay, so all the elements have images. Every element should have an image, and that image should be unique. But what I notice, students, I notice something very interesting. I notice that this element 2 of set A has 2 images. See, it has -1 as an image, it has -1 as an image, and it has 2 also as an image. So it means we do not have unique image for 2. So this set R1 is not a function from set A to B. Why? Because we are noticing that the element 2 does not have unique image. So it is not a function from set A to set B. Listen here. If I do the same thing in arrow diagram way, the one that we just saw, okay? If I write A here and B here, A has got 1, 2, 3, 4. B has got -1, 0, 1, 2, 3. So how will it go ahead? See, 1, 1, 0, you can check, 1, 0, 3, 3, 2 minus 1, 4 1, then again 2, 2. See, it will look like this. Okay, see, if you do the same thing, using arrow diagrams, then the diagram will come this way. What you are noticing? You are noticing that for 2, there are 2 images, and hence it is not a function. It is only a relation, not a function. Is this a relation? Is this a relation? Yes. Is this a function? No, it is not a function. So students, in case of ordered pairs, how can we go ahead? How can we say, see, remember, the set of ordered pairs is a function if you notice that the first component is not repeated. The first component should not be repeated. Here, the first component is repeated. See, 2 and 2. So whenever you notice in any of the ordered pairs, you notice that first component is repeated. The first component is repeated. You will say that it is not a function. Okay. So how we will write? We will write the answer as, before A, I will write the given set of ordered pairs. The given set of ordered pairs is not a function. It is not a function as the element 2, as the element 2 from set A has two has two images in set B. Or the other reasoning, you can say the first component 2 is repeated in two ordered pairs. The first component 2 is repeated in two ordered pairs. The first component has to be only once. I hope it's clear. The given set of ordered pair is not a function. It is not a function. I hope you followed it. Please copy this. So students, on the same line, we will go for second A, B, C, and D. Okay, let's begin. Look at second B, then C, then D. Come on, answer this, and then I will check.